There we go. Okay. All right, so now we're going to do advanced arithmetic. All right, so math is divided by the SAT test makers into 4 categories. You got your fundamentals, which we already did. Algebra, we already did it. Geometry and trig, which we're going to do. And then your 4th category is called advanced arithmetic. Okay, that 4th category, advanced arithmetic, is like everything else that doesn't fit in those other categories. So it's kind of a catch-all miscellaneous dumping ground for just everything else that doesn't fit. Okay. Consequently, the stuff in this category is going to seem like it doesn't go together because it doesn't. It's a miscellaneous dumping ground. But I made it flow as best I could. The good news is that pretty much everything in here is a calculator problem. The bad news is that most of it's word problems, which is going to make a lot of you go, oh, crap. Okay, but it is what it is. We'll make it as easy as we can. Okay, so let's start with ratios and proportions. Ratios are a relationship between numbers. They can be written in 3 different ways. Okay, you can write it as words, like the ratio of 2 to 3, which is completely not helpful to us at all. You can write it with a colon, like 2 colon 3. That's okay, we can work with that. Or you can write it as a fraction, 2 over 3. Okay, those are 3 different ways to write ratios. A lot of times in a problem, they're going to give you multiple ratios written in multiple different ways. One of your goals, one of your first steps, is going to be to write all the ratios in the same format. So either use all colons or all fractions. Okay, which one is going to be the most helpful will just depend kind of on the problem. And we'll look at different examples of that. Okay, one of the really popular types of ratio problems that you're going to encounter is what we call the horse race problem. It's not always about a horse race, but it has the horse race format. There's an example of this in the middle of your page. It says example. So the horse race problem goes like this. The purse or total amount of prize money for a race is $180,000. They're going to give you a total somewhere in the problem. The prize money will be divided into a ratio of 5 to 3 to 1. They're going to give you a ratio somewhere in the problem. First place gets 5 parts, second place gets 3 parts, third place gets 1 part. And then they're going to ask you about a specific place. How much will second place get? Okay. So this is the typical horse race formatted problem. There's 2 different methods to solve this. I'm going to show you both. You guys decide which one your brain likes better, and then just stick with that method the whole time. Method 1 is an equation. Okay, so your equation works like this. You take your ratio, 5 to 3 to 1. So we got 5 parts to 3 parts to 1 part. And we know when we put all of our parts together, we have to get our total. Okay, so when I add all my parts together, I should get 180,000. The problem is I don't know how much each part is worth. So that's my x. 5 parts to 3 parts to 1 part. And again, I know when I add them all together, I should get my total. Okay, solve for x to get the value of each part. So 8, 9. 9x equals 180,000. So each part is worth 20,000. And then just go back and answer your question. So how much will second place get? Second place is going to get 3 parts. So 3x, 3 times 20,000 would be 60,000. So second place is getting $60,000. That's one way to do the problem. Okay. Your other way to do the problem is very similar. It just doesn't involve an equation. Your other way to do the problem is what we call total over total. So the total over total method goes like this. You look at the total that they give you in the problem. So the total in our problem is 180,000. Put that on top. On the bottom, you put your total number of parts. So the total number of parts would be 5 plus 3 plus 1, that's 9. 180,000 divided by 9, that's 20,000. So that's the value of each part. Once you know that, you can answer your question. How much money would second place get? Second place gets 3 parts. So 3 times 20,000. So either way, you're going to get to the same answer. You just have to decide whether you want to use x's or whether you want to do this. And whichever way your brain wants to do it is fine. Doesn't matter. I use that one. Well, yeah, but you got to remember, I went all the way through like master's level courses in math, and so I'm kind of trained to do it this way, and this is how I grew up doing it. And I have a lot of students that are totally adverse to using equations, like they hate using equations, and that's when I kind of came up with this. So this is the way my brain has been trained. But if your brain doesn't like equations, do it this way. No big deal. As we do our ratio questions, I'm going to do some one way and some another, so you're going to get exposed to both. That's my goal. Yes, ma'am?
I just want to double check. So somebody's asking for second place without me, that's 40,000?
No, second place is 3 parts, because it's 5 parts to 3 parts to 1 part.
Oh, I see. Okay.
Yeah.
Thank you.
No problem. Any other questions on this? All right. Yeah, when I was growing up, this is the only way they taught ratios. Or at least where I was growing up, that's the only way they taught it. Okay, number 12 at the bottom. So sometimes your horse race problems come disguised as chemistry problems. So even though it looks like a chemistry problem, it's not really a chemistry problem. It's actually a horse race problem. It's just in disguise. So let's look at that. That's at the bottom. All right. So at the bottom, we have an acidic solution is mixed so that the mass ratio of nitric acid to water is 2 to 7, and a total is 270 grams of acid in a solution is mixed. How many more grams of water are there than nitric acid? So again, let's look at what they gave you. They gave you a ratio, 2 to 7. And they gave you a total, 270 grams. That's no different than what we were given in the horse race problem. Okay. All right, so let's do this one as total over total. So total is 270. Total of my ratio, 2 plus 7 is 9. Divide, 270 divided by 9 is 30. So each part is worth 30. Go back to my question, how many more grams of water are there than nitric acid? That means I need to know the amount of water, I need to know the amount of nitric acid. The way the problem is written, it says that it's the ratio of nitric acid to water. So that means my numbers come in that order. So the 2 is the nitric acid, and the 7 is the water. So the nitric acid gets 2 parts, the water gets 7. So nitric acid is going to be 2 times 30, which is 60, and water is going to be 7 times 30, which is 210. And they want to know how many more grams of water are there than nitric acid. How many more means to subtract. So 210 minus 60, which is 150. Can't write. There we go. And that's C. Any questions on it? Yes, sir.
I did it a different way. I don't think I thought it was like.
Oh, no, go for it. There is another way to do this. I'm guessing the way you did it is probably the way I don't show people because they freak out. But go for it.
I noticed that the ratio was 7 to 2, so I did 7 minus 2 was 5, and 5 times 30.
Yes, absolutely. Yeah, that's like the shortcut way. And if your brain sees it, go for it. If I show people that right off the bat, they usually go, "What kind of witchcraft is that?" So I don't usually do it. But yes, absolutely, that's a shortcut way. If you see it, do it. Okay, ACT 15 at the top. That one's yours for homework. And again, either method is fine, whatever works, whatever floats your boat. Let's look at ACT 35. Fractions. Jerome, Kevin, and Seth shared a sub sandwich. Jerome ate half the sandwich. Kevin ate a third of the sandwich, and poor Seth got the rest. What is the ratio of Jerome's share to Kevin's share to Seth's share? All right, so our goal here is Jerome to our buddy Kevin to poor Seth. Jerome got half. Kevin got a third. We all know what Seth got. How can I figure out how much of this sandwich poor Seth got? What can I do? Yes, ma'am? You got it. So you guys have calculators? Go for it. Add these two together, subtract it from 1. If you don't know where your spiffy diffy fraction button is on your calculator, ask me. I'd be happy to tell you. It's my favorite button ever. If you're on a TI, just 1 divided by 2 plus 1 divided by 3, and then go into your math menu. Hit option 1, arrow frac. Choose that, it will flip it back into a fraction for you. Favorite button. Love that button. All right, so how much did poor Seth get? 1/6. He only got a 6 of the sandwich. Poor guy. Probably still hungry. Okay, so there's our Jerome to Kevin to Seth. Now that's not one of my options, my answers. My answers are all whole numbers. Okay, so in order to switch this into another ratio that's all whole numbers, okay, one of my legal moves with ratios is to multiply or divide everything by the same number. That's a legal math move. I can't add or subtract, but I can multiply or divide as long as I do it to everything. What can I multiply all these numbers by and get rid of those fractions? 6. There we go. Yeah. 6. Common denominator basically is what you're looking for. If you're looking for the common denominator of all three, which is 6. Okay. So multiply by 6. Half of 6 is 3. 6 times a third is 2. And if you don't, like I said, if you don't know that, just use your calculator. 6 times 1/6 is 1. So an equivalent ratio to 1/2 to 1/3 to 1/6 is 3 to 2 to 1. And that is option D. Okay. Number 19 is yours to do for homework. Top of the next page, ACT number 4. The ratio of 2x to 5y is 1/20. What is the ratio of x to y? So 2x to 5y is 1/20. And they want to know what x to y is. Well, first of all, we know written as words, it does not help me in any way, shape, or form. So I'm going to write these all as fractions because we know, at least in a math problem, I can do mathematical operations with fractions. So 2x over 5y, the word is means equals 1/20. Now, what am I looking for? I'm looking for x to y. So they want me to find x over y. All right. One of the things that your ACT loves to do is actually embed the answer to a problem in the problem. Okay. So I'm looking for x over y. Well, guess what? It's right here. It's already in my problem. I just have to get it by itself. So I just have to get rid of the 2 and the 5. How do I get rid of 2/5? Multiply it by 5 and divide it by 2, right? In other words, just multiply by the reciprocal. Anytime I want to get rid of a fraction, just multiply by the reciprocal. That's an old Algebra 1 thing that you guys haven't seen Algebra 1 in, God, I don't know how many years. So multiply both sides by 5/2. I'd say roughly 90% of my SAT kids have forgotten how to do that. Just because you guys don't, y'all are in like crazy advanced math classes and don't remember Algebra 1. Okay. This side you wind up with 5/40. And then just reduce that. So 5/40, if we divide top and bottom by 5, that's 1/8. So x over y is 1/8, which is D. All right, SAT number 17 is a trick question. I hate this question. So take a minute to read through SAT number 17. I thought they were doing High School Musical.
I know. I can see color switching it up today.
Apparently. That's Greatest Showman. I'm like, oh. Okay. Does anybody spot the trick at number 17? And I don't blame you if you don't. Here's your trick. Or here's your hint. Look for a relationship between a number in the problem and one of your answers. What number did they give you in the problem? What number in your answers is related to 5? That's your answer. Here's your explanation. So they tell you that the ratio of boys to girls in the class is x to y. So boys to girls, the ratio of boys to girls is equal to the ratio of x to y. They tell you the total number of kids in the class is 5 times the number of boys. Well, the total number of kids in the class is going to have to be the number of boys plus the number of girls. Okay? Now, if these ratios are equal, then that means my total number of kids in the class could also be, actually just be my ratio. It could also be x plus y. Or it could be a multiple of that. Okay? But this is a possibility. This is a possibility. What do we also know about the total number of kids in the class? What else did they tell us about the total number of kids? Yes, ma'am. Which means it has to be divisible by what? What's the only answer divisible by 5? There you go. That's how I get there. Okay? That is the only way to figure out that problem. You cannot solve for x and y. You cannot figure out the total number of kids in the class. You cannot figure out the number of boys and the number of girls. Yes, ma'am. So that was actually going to be the next thing we're going to talk about. They actually repeat this question quite frequently. But here's the good news. The only thing they change is the teacher's name and the number. The rest of the wording in that problem is exactly the same. So all you have to do is zone in on that number and look for your answer that's a multiple of that number. Sure. So the total number of kids in the class has to be boys plus girls, right? I mean, that's just common sense. Okay? But we know that the boys to girls ratio is the same as the x to y ratio. So a possibility is that our ratio, the sum of our ratio, is also equal to the sum of boys plus girls. That's a possibility. Okay? So if that's the case, then the x plus y would also equal the total number of kids in the class. Okay. What do we also know about the total number of kids in the class according to the problem? Which means it has to be divisible by what? What's the only answer divisible by 5? So it's got to be that. That's got to be the total. It wouldn't matter. It'd still have to be divisible by 5. The way they set the problem up, it's going to have to be divisible by 5. Like I said, the only thing they'll change in this problem is the number and the teacher's name. So just zone in on that number and pick the multiple of that number. But that's why I hate this question, because it's a trick. I can't figure out x and y or b and g, and it drives me nuts. Okay. Any other questions on this one? Okay. You're going to find the questions that I put in my packets, these are ones that show up repeatedly. I don't give you one-offers. So that's why they're in the packet, is because they're ones that are repeatedly used. Okay, proportions. SAT number 5. Okay, so let's talk about proportions first. Proportions are just equations with ratios on both sides. That's all they are. The biggest way people screw up proportions is they wind up flipping one side of the ratio. Okay? So like if you're doing dollars per day on one side, people will flip the other side and do days per dollar. That's how people screw this up. You want to make sure you do the same thing on both sides. The easiest way to make sure you do the same thing on both sides is make yourself a really quick label of what's on each side of your proportion. And we're going to show you how to do that. So SAT number 5. If 2 packages contain a total of 12 donuts, how many donuts are there in 5 packages? This is a really easy problem, guys. I know you can solve this with common sense. But let's look for the method. Let's look at how we do this with a label. So you have 2 things going on. You have packages and you have donuts. You can either do packages over donuts or donuts over packages. Doesn't matter. I'm going to do packages over donut. Okay, that's my label. That's as complicated as my labels get. It's not something that's going to take me a long time. But this is just going to keep my brain straight so that I know on both sides of my proportions, I need to do packages over donuts. So I have 2 packages that contain 12 donuts. and I want to know how many donuts are there in 5 packages. So I have 5 packages, but I don't know the number of donuts, so I put an x, cross multiply and solve. 2 times x is 2x, 12 times 5 is 60, divided by 2, x is 30, there's 30 donuts. Okay. Again, I know this is an easy problem and you can get there other ways, but we're looking at the method. Okay. All right, bottom one is yours for homework, ACT number 3. Next page. Let's look at what happens when they mess with your answers. Number 26 at the top. Anita created a batch of green paint by mixing 2 ounces of blue with 3 ounces of yellow. She must mix the second batch so that the same ratio of blue and yellow paint are the same as the first batch. If she uses 5 ounces of blue in the second, how much yellow should she use? And then they give you funky answers. So first step, actually solve the problem. Let's find the amount of yellow. So again, I'm going to make a quick label. I'm going to do blue over yellow. You can do yellow over blue. It doesn't matter. Bathroom's over there. Okay. All right, so first batch, we have 2 ounces of blue and 3 ounces of yellow. So 2 ounces of blue, 3 ounces of yellow in the first. Second batch, she's got 5 ounces of blue. Blue goes on the top. She wants to know how much of yellow. So that gets my x. Cross and solve. 2 times x is 2x. 3 times 5 is 15. 15 divided by 2 is 7.5. So she should have 7.5 ounces of yellow. Okay. All right, let's look at our answer choices. A says exactly 5. Well, obviously that's not 7.5, so A is out. B, 3 ounces more than the amount of yellow used in the first. So if I'm calculating B, 3 ounces more than would be 3 plus. The amount of yellow used in the first, the amount of yellow used in the first was 3. 3 plus 3, that's 6. That's not 7.5. B is out. On to C. C says 1.5 times the amount of yellow used in the first. So that's 1.5 times 3 again. We just had that. 1.5 times 3 is 4.5. Again, not 7.5. C is out. Process elimination, it better be D. And if you calculate out D, you do get 7.5. All right. On to number 21. Gary. Oh, Gary. Gary has an ego problem. All right. Gary is using a 3D printer to create a miniature version of himself. He's making a mini-me. The scale of the miniature is 0.4 inches to 1 foot of Gary's actual height. Gary is 5 feet 9 inches tall. What will the height of his 3D mini-me be? This problem has all sorts of issues besides Gary. He's got mixed units, 5 feet 9 inches. We don't do that in math. That's disgusting. Okay? Our scale is also mixed, 0.4 inches to 1 foot. Not a fan of that either. We could make that work, but I'm not a fan. To figure out which way you want to go, to feet or to inches, look at your answers. What are your answers in? Inches. Let's convert to inches at the beginning, and I don't have to do it at the end. So we're going to make all this stuff in inches. Okay? So my scale then, instead of being 0.4 inches to 1 foot, I'm going to make that 0.4 inches to 12 inches. Okay? And then Gary being 5 feet 9 inches tall. 5 feet 9 inches, how many inches tall total is that? 69, yeah. So Gary is now 69 inches tall. All right, so there's my data. So again, we have a choice. We have mini-me and we have Gary. So we either got to do mini-me over Gary or Gary over mini-me. It doesn't matter. I just need to be consistent. I'm going to do mini-me over Gary. So there's my label. All right. So my scale is 0.4 inches to 12 inches. I'm assuming that the miniature is going to be the 0.4 because that would be smaller than Gary. So the mini-me is the 0.4. Gary is the 12. Squeaky marker. On the other side, I don't know the mini-me, but I know Gary is actually 69 inches tall. Again, cross and solve. We got 12x equals, okay, I'm out of mental math at that point. Calculator. $27.6. And then just divide by 12. 2 point, I don't know what. There we go. So 2.3 should be our height of our mini-me. All right, any questions on our buddy Gary and his ego issue. Okay. ACT number 5 is yours to do for homework. Let's look at ACT 34 at the bottom. A school admissions office accepts 2 out of every 7 applicants. Given the school accepted 630 kids, how many applicants were not accepted? Okay, we gotta be really conscious of our label here. When they say they accepted 2 out of every 7, what's your label gonna look like? 2 out of every 7. Is that accepted over not accepted or accepted out of total? It's accepted out of total. We need to really keep track of that on this one, and you'll see why in a minute. So my label is accepted over total. Okay. So they accepted 2 out of every 7. So I got 2 out of 7 on one side. Given that the school accepted 630, so accepted goes on top. I don't know the thing on the bottom. Again, cross and solve. So 2x equals, large number, 4410. Divide by 2, that's 2205. Okay, now thankfully, you won't get tricked into an answer because I don't think that's one of your answers. But again, this is where your label comes into play. What did we just find? No, but that's not what we found. That's what we want. That's what we want. But what did we just find? We found the total. So how am I going to get the number that weren't accepted? Yeah, just take off 630. Because if this is my total, and I got 630 that were accepted, then the number that weren't accepted would just subtract. So 5, 7, 1575, I think, if I mental math that correctly. All right. So everything we've done so far as proportions have been direct proportions. With direct proportions, you have fractions on both sides, and as one quantity goes up, the other one goes up. As one goes down, the other one goes down. They do the same thing. They are direct. There's another type of proportion out there called the inverse proportion. And it is exactly what it sounds like. As one quantity goes up, the other one goes down. As one goes down, the other one goes up. They just work opposite. Okay? All right. So let's look at an inverse type problem. Now, what do you have to remember about inverse proportions? First of all, they're very, very easy to spot because they will actually say such and such is inversely proportional to such and such. It comes out and tells you it's an inverse proportion problem. You don't have to guess. Okay? What you have to remember is to switch up your equation. So instead of having fractions on both sides, you're going to multiply on both sides. Okay? So you're going to do x1, y1 equals x2, y2. Okay? So instead of dividing, we're going to multiply. That's the only difference. So let's look at an example. SAT number 15. This is on page 5. The amount of time it takes to consume a buffalo carcass is inversely proportional to the number of vultures present. You got more birds, it takes less time to eat the buffalo. Makes sense. If it takes 12 vultures 3 days to consume a buffalo, how many fewer hours will it take if there are 4 more vultures? All right. So in the first case, you don't really need a label with this one because you're multiplying, so order doesn't really matter. So in the first case, you have 12 vultures taking 3 days. And you can either leave this in days currently, or you can switch it to hours now. I'm going to choose to leave it in days at the beginning, and I'll switch it to hours at the end. But you can do it either way. Now, in the second case, we have 4 more vultures. So 12 plus 4 would be 16. So now I have 16 birds, and I want to know the amount of time it's going to take. That's kind of my first step. So 12 times 3 is 36. It is going to be 36 divided by 16. It's 2 point something. 2.25. So it's going to take them 2.25, and I'm still in days here. So it's going to take them 2.25 days now to eat the buffalo. Now they asked me how many fewer hours it's going to take. Well, I haven't figured out the how many fewer part at this point. So let's do that. How many fewer days is it going to take? How would I figure that out? Right, you're just subtracting. So the number of days it took before minus the number of days it took now, that's 0.75 days. So it's going to take 0.75 fewer days and then convert that to hours. So there's 24 hours in a day, so multiply by 24. And you should get 18. It's going to take 18 fewer hours. Okay. All right, next up is percentages, but let's take a break. Let's take a break and we'll come back to do percentages. Whoops.